Hi, today we're going to do number 230, kth smallest element in a BST. So we're given the root of a binary search tree and an integer k, return the kth smallest value. So we can see here we have a tree of 3, 1, 4, 2. K is 1, so we want the first smallest value, and that will be number 1. In here we have 3, so 1, 2, 3, we return 3. So the key here is to know that we need to do BST left node right is the order is like ascending order from smallest to least for BST. So we need to use a in order traversal. And then if we go from smallest ascending, if we do an in order traversal here, we can just stop at when we get to the kth value. So there's two ways we can go about it, using recursion or a stack. So with recursion, we need to perform this in order traversal. And before we do that, we need to create a count. Create a count, and then empty value for the returned value. So then we traverse in order with the helper function. And then we keep count of nodes visited. And then once we get to k being the count, we just return that node's value and we'll have the answer. So the time complexity here is going to be O of n, or n is the length of this because we can be traversing through this entire tree if it's all the way at the end. And then the space complexity is going to be O of h, where h is the height of this tree, because we're creating a call stack for the longest height. So how else we can do it is to use a stack. And when we use a stack, we pretty much replicate in order to traversal, where we push all the left values to the stack, and we do this in a while loop, and while as long as the stack is empty and current is null. And we're going to need to create current pointer values to the root to know what we're going to keep track of. And then we push all the values to the left side of the stack. We do this while current is null. And then we can, once we have all the values, we go down all the way to the left, we pop the current value, increment count. So we're going to need to create a count variable again. Or we don't really need increment count, we decrement k until k is 0. If k is 0, return the node value. Otherwise, we just add the make current equals current dot right to go on the right side. And for this, it's going to be the same as well. The time and space complexity is going to be O of n, and space complexity is going to be O of h. And since the recursion one is more simpler and kind of the stack kind of mimics a recursion in order traversal, where recursive we can just do it in order. I will go with the recursive way, but I'll show you both. So here we create the count. And now we create the kth value, we can call it. And we say, I don't know. And that's what we're going to return, kth value. And now we create this helper function in order that takes in a node. And we'll be calling this at the root. Here, if node is null, we just return. Unless we want to go to the left, so in order node.left. And here's where we're going to do the count, so count plus plus. If count is equal to k, kth value is equal to node.val, and we turn out of it. Otherwise, we can in order to the right. Great. And now we can do it with the stack. So in the stack, we have the same idea. We can keep the count actually and kth value. So we need a current. And it starts off looking at the root, being the root. Turn current dot val. And now we do a while const, we create the stack. And it starts off at current. So while stack.length is greater than 0, or current is true, there's a value for it. First, while there's a value in the current, we want to add all values to the left. So stack.push current, and then we want to go to the left. Now we pop it, so const node equals current dot pop count plus plus. If count equals to k, return node.val. Otherwise, we just update current to the right. We don't actually need this. All right, we'll pop it from the stack. Oh, so when we pop it, this is what our current is going to be to see what we're currently looking at. And what we're going to turn will be current.val. Great. I know in the comments I said we decrement k, but we can keep the counter as well. So here, the key here is to know that the BST is in lowest, it's in order from left, middle, right. So we do a in order traversal, and as we do that, we keep track of how many nodes we've seen and we can use the count variable. If that count variable gets equal to k, we know that we return that value. And that's all. Thank you.